in Buddhist philosophy and quantum physics. For this, we have Dr. Ravi Prakash Ji, psychiatrist and neurophysiologist, who will be chairing the session. And we have Venerable Geshe Doji Damdula, Director, Tibet House, and Professor Ujjwal Sen, Harish Chandra Research Institute, Allahabad. Unfortunately, one speaker was not able to attend today, so we have only two speakers for this session. May I request the speaker and chairperson to take their respective seats on the dais. To save time, I'll not reintroduce Dr. Ravi Prakash. May I request Dr. Ravi Prakash to chair the session?
So it's a great honor, first of all, for me to be chairing a session with such allied guests here and presenters. So I'll directly come to the session. It's already running late, as we have been told. So this is the second session. The theme is Causation, Free Will and Indeterminism in Buddhist philosophy and quantum physics. Very, very important topic, very intriguing, and this is one, free will at least is one topic that binds many different fields, so it is very integrative in nature. So we have with us, as it has been mentioned, one of the speakers will not be speaking today. So we have with us two speakers, honorable speakers. First, I would like to introduce the first speaker. Venerable Geshe Doji Damdul is currently the director of the Tibet House, the cultural center of His Holiness the Dalai Lama. He travels widely within India and abroad to teach Buddhist philosophy, psychology, logic and practice. He has also worked on several books. As assigned by the office of His Holiness the Dalai Lama himself, he visited US in 2008 to work with Professor Paul Ekman. Very interesting. Professor Paul Ekman, yeah. On His Holiness, the Dalai Lama's book, Ethics for a New Millennium Part 2, and the book series, Art of Happiness, which was jointly written by His Holiness and Dalai Lama. He has written a number of papers for national and international conferences on topics such as the paradox of brain and mind and ultimate reality according to Arya Nagarjuna. So I humbly invite Sir for the presentation.
Okay, thank you. Thank you so much, Mr. Chairperson, and all the participants here. The topic here, which you can see here, the causation, free will, and determinism in Buddhist philosophy and quantum physics. Some of you who are already aware about these debates. You may be excited. Otherwise, it seems like, what is this? This is something so obvious. Free will, determinism is so obvious. It's not obvious. It's quite a complicated the topic. And then by the way, how much time I have? 20 minutes? 15, 20?
I'll speak.
20 minutes, okay. So as I go through these slides, you come to unfold as to how challenging this topic is, and it's a heated the topic of discussion in most of the disciplines. Okay. First, let's say that the free will, causality, determinism, where is these things, this discussion, the debates, where are they going? Where? What kind of what kind of disciplines, where these things are discussed. Number one, philosophy. And of course, the philosophers, they have lots of things to discuss in this. And then the psychology, physics, neuroscience, theology. First, let's say before we go into the individual talks, the disciplines. Let's say what do you mean by free will, and what is meant by determinism. If you read Albert Einstein's writings, you see that there's a tremendous discussion on the determinism of free will, and Einstein is more into determinism. And then the free will, not really free will, he is into determinism versus randomness. So he was not really happy with the randomness concept, uncertainty principle. And of course, the determinism is determinism as opposed to randomness, not really with the free will. But then the debates were hovering around this. So therefore, there are two things there: free will and randomness. Do they mean the same thing? Likewise, determinism, causality, and karma. Karma. This is the more theological word, or the religious term, philosophy. So do they mean the same? This is a question. Sorry. Okay, first in philosophy. Let's say, generally speaking, in philosophy, in the classical philosophy, let's say, the Charvaka tradition is the one who rejects the more like the determinism, the cause-effect relationship. Of course, the evident cause and effect is what they are not rejecting. Cause and effect related to something, the unseen cause-effect. Say, the universe came from where? The universe, the physics would say the Big Bang theory, from the Big Bang. So the pure Big Bang came into being. But the Charvakas, they would say that things, they arise randomly. So there is the concept of randomness there, Charvakas. And then solipsism in the West, the concept of solipsism, which believes that there's only the self. The self is there, I'm there. All others, they're just illusion. So like with respect to you, you are there, but all others are illusion. This is solipsism. So these two reject the concept of the more long-term cause effect, or the determinism. Okay, sorry. Okay, now with the physics. Physics, we see that the classical Newtonian physics is there, then the relativity theory is there, then quantum physics is there. Say the classical Newtonian physics is more in line with the determinism. More in line with determinism than the relativity. The Stephen Hawking, Einstein, he is very much into the concept of the determinism. He's totally against the probabilistic and the randomness concept. So therefore, it is the quantum physics where the randomness and the probability, these concepts become so important, like the central concept of the quantum physics. So we see that. Then the free will, causality, determinism, more into quantum physics, we talk the Heisenberg's uncertainty principle. So there, then there's this, that the observer observed, and at a particular time, the momentum and the mass of the object, they cannot be determined very precisely, both simultaneously. And the quantum entanglement, which some physicists discussed this morning, and also the professor, the Pratap Ghosh, he also discussed on this, teleportation, then the quantum non-locality, Okay, so there we see that the probability and randomness, these things, from there, then all these concepts, they come to being. And okay, the quantum vacuum is also another important part. Then the free will, causality, and the determinism in biology and neuroscience. Say of course, when we speak about the free will, it's to do with our will, it's with the thought process, a mind. And Charles Darwin, who came up with the concept of the evolutionary theory, Charles Darwin's evolutionary theory. So there, like 0.3 million years ago, the Homo sapiens came into being, and then now the concept of the free will, whether we have the free will or not, is more related to the human thought process. Whereas, according to Charles Darwin's evolutionary theory, all the other animals, they are more seen as operating more through instinct and so forth. Human beings, if there is a free will, is more to do with the Homo sapiens. So now this debate, free will, causality, determinism, in theology, there are so many debates happening. Inter-debates happening, intra-debates happening. And then, like, say, the inter-debates between different religious traditions. And the intra, for example, those who accept God, the theistic religions. There, the great scholars, within the theistic religion, we see that there are many scholars, brilliant intellects are there, so they freely come with this, debates. If there's God, then you don't have the free will. You're all fixed by the God. And if you have the free will, then the God doesn't have there's no God. So all these debates were heated debate then, particularly in Christianity. In Christianity, all these giant philosophers, also the priests, they will come up with, they very courageously come up with these thoughts, and then some of them go through torture because of these debates. Okay, then this one thing is a huge debate, and if you're interested, just Google search, all these debates come there. And if you are a very pious believer of God, don't go through these debates. Okay. Likewise, the next part is those who accept the law of karma. For example, most of the Hindu traditions, classical Indian traditions like Samkhya, Vedanta, then the Mimamsaka, Vaisheshik, Nyaya, and then Jainism, Buddhism, all these traditions, except for Charvaka, they believe in the law of karma, and then karma versus the free will. Again, karma means that what I'm now is determined by my previous karma, right? So I don't have the free will to decide what I'm today. How would you then reconcile these two concepts, the free will and karma? This is a very important discussion. Okay, so with this very brief intro where these debates are happening, this is a very serious debate. In fact, some of the morning presenters, they also came up with these ideas. They had to come up with these ideas, free will and so forth. Last year, in the month of May, I was in Israel for a conference on consciousness. And the conference was organized by a very senior neuroscientist, Israeli neuroscientist, and who is also a well-renowned neuroscientist in Europe. And he convened the conference, and I was there as a presenter. Then as I was listening to the neuroscientists, their presentations, they started to beginning with a different topic, they ended up into the free will debate, neuroscientists. And then they try to reduce of course, free will. If there is, it should be a part of your, mental activity. And the mental activity for the neuroscientists, one is here, and one is here, and some neuroscientists are here. So according to neuroscientists, hardcore neuroscientists, your mental activities are to be reduced to brain activities, and brain activities to be reduced to the neurons. Activities of the neurons, and the neurons activities to be broken down into the chemical reaction, electrical impulses, electrical signals sent from one synaptic connection to the other, neural firing. So they reduce. They have to reduce today. In the future, we never know. There could be paradigm shift in neuroscience, but today they have to explain the mental activities are reduced to the brain activity and finally to the electrical and the chemical reactions. Okay, then this free will concept came into being. Then they had a heated debates. Nothing could be resolved because if it's purely mechanical, then the way presented, particularly by our chairperson during his presentation, if it's purely mechanical, then it's not an effects for, let's say, what the universe was 15 billion years ago at the time of Big Bang. From there, if you have a particular, this system by which to determine all the variables there, they can precisely predict what is happening 15 billion years from that in the future, from that point, which is today. What is happening today that we are sitting here in the Indian Institute of World Culture, sitting here, how many people and what lunch you had, all these are fixed if there's no free will. So this was the thing, and then but whereas this is not fixed. And then again, I think Dr. Ravi, he mentioned about the ethics, then about the law, about the court cases, law, then the election system. Election means I'm using my free will to decide who the prime minister should be, who the president should be. I'm using my free will. So all these concepts simply dissolve. You have to deny all these concepts. So this debate, nothing could be resolved. So that's the question. This is a huge debate in neuroscience. It's a huge debate in physics. It's a huge debate in philosophy. Okay. So this is what this morning somebody said, that quantum physics, it talks about the probability, randomness, and so forth. And this we cannot deny that because that we have the free will to determine who the president, the prime minister of the nation should be like, and what you're going to have for your lunch, whether you're going to have the lunch or not, whether you're going to have the South Indian lunch or not. So you have the free will, and then deny the quantum physics about the probability, randomness. This is undeniable. So what is fact cannot be denied. So how are we going to reconcile these things? And quantum physics, on the one hand, is extremely profound. Likewise, the concept of the karma, concept of the cause and effect, presented in the various classical Indian traditions and the Buddhist philosophy, Buddhist psychology, is also likewise extremely profound. This is a word by the Buddha himself: profound, peaceful, free of elaborations, clear light, non-composite. Such an actor-like reality is what I found. Finding no one who can fathom this path, in silence I'll return with words. So he said that profound and peaceful, profound. This path which he discovered was so profound. The way quantum physics is shared. If you study quantum physics, if you are not shocked by it, you have not understood it. So likewise, the reality which the Buddha discovered, of course, is so profound. Again, in this concept, we talk about the free will. We talk about, many such concepts. So how would you reconcile these two things, free will and determinism? This is a very serious matter. Okay, so now this is a big question, and if the manner in which the discussions was happening, Israeli conference on consciousness conducted in Israel. So there, then the neuroscientists, the psychologists, even among the neuroscientists themselves, all these debates, nothing can be resolved. So then I stood up and I said, this will never be resolved unless and until you understand one concept. That is objectivity. You have to know the objectivity so well. Objectivity, what constitutes the objective reality? If you don't know this, then this debate will just keep going endlessly till the end of the era. So that approach, to know the objectivity means your approach must be very objective. Your approach must be very objective. It should not be sullied by the baggage of the philosophy, of the neuroscience, or the physics, or whatever. You should not think that, okay, other traditions are not so the mind one represents. No, you should really come up with a clean slate. That is the meaning of the objectivity. So this is what the Buddha said. Just as a goldsmith tests the purity of the gold by cutting, rubbing, and burning the gold, you should also examine my words and put them into practice, not simply because you respect me. This is so important. In other words, don't rely on blind faith. And people can follow science blindly. Even people can follow neuroscience blindly. So your approach must be very objective. You should not be followed blindly. Okay, so in this connection, then this morning there was a debate, Pratyasamutpad. What is Pratyasamutpad? Whether or not it is, dependent on the causes and conditions or dependent on the mind, subject, all these debates. So there, to know what is objectivity, we have to know these three levels of dependent origination. That everything that comes into being, that comes into existence, the empirical reality, this is what I'm saying. This is my emphasis, empirical reality, to not offend in other traditions. Empirical reality which we can feel, which we can the experience. So that reality should necessarily fall under these three levels of dependent origination. So this morning, the questioner was asking about the first one, dependent origination of the cause and effect. Cause and effect went behind this picture. Okay, it was just cause and effect. The second one is dependent origination, whole past. And the presenter this morning, Dr. Pranchuji, was saying dependent origination of the mere mental destination, subjective destination. So there's no contradiction there. It's just a matter of the matter of the subtlety. The presenter was making the subtlest presentation, and the questioner was asking the first one, dependent origination of the cause and effect. So if you don't understand these three things, dependent origination, three levels of dependent origination, then you cannot see the objectivity, because the objective reality that we're going to discover is that nothing really exists independently. This is reality. That nothing exists independently, that is the reality. And for that we need to know everything does exist, but they exist by dependence on three different ways. So with this, then I talked about this concept, and where this morning one presenter, the physicist, the lady physicist, okay, this is a very important concept. And in Israel, for their conference, there was neuroscientists and a very senior physicist also. And then the physicist was cornering the neuroscientists, and neuroscientists didn't know how to run away from this debate. Okay, so I said that without understanding this, this question will never be resolved about the free will. How? One, the macrocosm and the microcosm. For example, say with the physics, we have quantum physics. Quantum physics, which mainly deals with the micro reality, microcosm, and the relativity theory, which mainly deals with the macro reality of the universe and so forth. So these are the two realities of the same object, and yet if you treat them separately, and if you apply the laws which governs the macro to the micro, it will fail. And the laws which govern the micro, if you apply to the macro, it will fail. For example, let's say that if I ask you, what is this? What is this? Right? Most people say this is water. But the physicists will say that this is electrons, protons, neutrons. That's true. And who is correct? Both are correct. So when you say that electrons, protons, neutrons, which constitute the water, and electrons, protons, neutron, which constitute the rock, there's no difference. But on the functional level, there's a difference. Rock, you cannot drink it, you cannot eat it. It can kill you. But the water, you can relish it, you can drink it. So the basic constituencies is the same. On the micro level is the same. On the macro is very different. So these two we should appreciate. We should treat the two realities of the same thing. Same object, the two realities must be treated separately. So with this in mind, when you treat it on the functional level, we call it conventional truth. When you treat it on the macro level, we call it ultimate truth. This is the thing. And then say what is similar to quantum physics, we see that the contemporary physics is that the quantum physics deals with the macro and the relativity theory deals with the macro. So so there's no contradiction there. Okay, let me go directly to the main point. Main point meaning the. Okay, in other words, let's say down there it is His Holiness the Dalai Lama with the physicist, very world-renowned physicist, Anton Zeilinger, Professor Anton Zeilinger, and okay, so there, what they're talking about is that things are subjectively real. That what's the reality out there? One, what is this? Water. One, this electrons, protons, neutrons. Both are correct. Both can be correct only if you realize that from the object there's nothing, there's water is just a perception. From the object there's nothing, there's electrons, protons, neutrons, this is your perception. On the perception level, on the conventional level, both operate. On the objective level, there's nothing there as one entity. If this is what you've realized, then everything becomes purely subjective. On the subjectivity, depends on how you perceive it. Then the subjectivity comes to being. So if you look at it from a very gross perspective, when you're thirsty, you look at it, you see water. Then through electron microscope, you look at you see electrons, protons, neutrons. So it's the same object seen in two different ways, and two things are seen. So if you admit that, then the free will and the determinism. Let's say, guess what? Am I going to pick this water bottle or not? Guess. If you say yes, I will not pick it. If you say no, I will deliberately pick it up. Which means that I'm using my free will. Right? Am I going to drink this? Right? If you say I will not drink it. If you say no, I'll drink it. And now, if you say maybe, I'll deliberately drink it. Right? Okay. So with this, what I'm saying is that there's no contradiction there. So it is, if they say one is operating on the macro level, which is that I use So why did you drink it? Because they said that I'm not going to drink it. I want to challenge them. So I use my free will to challenge them. I use my free will. This is how the free will is understood in the conventional world. We are not to create a definition of free will on our own. It must be defined the way it is understood in the conventional world. So there, I use my free will. And then you ask me more closely, you say, why did you do it? I want to challenge them. So wanting to challenge them, that is a cause which made me to drink it. With the other factor that you said, no, you're not going to drink it. These two causes are there, then I drank it. That's the result. That is determinism. So in other words, this is a cause-effect relationship operating. And on the macro level, this is a free will. On the macro level, cause-effect thing is operating. There's no contradiction there. So if you blend the two levels together, then the problems arise. Okay, I know I'm finished. Okay, I'll stop here. I don't want to bother the chairperson. Okay, thank you so much.
Thank you very much, sir. Very, very lucid presentation, I must say. And the way Venerable Dorji sir, he described all the terminologies, free will, determinism, randomness from different perspectives of philosophy, physics, biology and neuroscience and theology. It was very interesting to see how the correlations can be made in one branch from another branch. So that is very interesting. And other than that, Sir went on to explain the importance of objectivity, ontological reality, macro versus micro. This was very interesting for me. At macro level, my take-home message was that at macro level it is free will, and at micro level it is cause and relationship. Yeah, that's very interesting concept for me. So with this presentation, we will move ahead. Our next speaker, Professor Ujjwal Seth. He did his master's from the University of Calcutta and PhD from the University of Gdansk. I hope I'm pronouncing Gdansk. The latter being with Ryszard Horodecki. Subsequently, he was Alexander von Humboldt and Raymond Y. Kajal fellowships he respectively received in Hanover and Barcelona with Massey Levinson, very big scientist. He was briefly a faculty at the Indian Institute of Technology, Delhi, and is currently at the Harish Chandra Research Institute, Allahabad. He works on quantum information and computation and its interface with other sciences, another of the integrating concepts we are going to have. And he will be presenting on the question, what is entanglement? The very basic question, what is quantum entanglement? And not much to say, just 20 minutes of presentation, sir. And we'll start with the presentation. Thank you.
Hello. Yeah, I'll begin by thanking the organizers for giving me an opportunity to speak here. I have spoken before in a similar event a few years back. So I'll begin. So I will, as the chair announced, I will be talking about what is entanglement, and but I will begin with why I ask this question. Yeah, so we have heard a lot from the morning about quantum mechanics. Yes, it claims to describe all of nature. I mean, it's a bit of a big claim, but that is the belief. And it was formulated in the 1920s, around that time, by many people, and these are a few names. This et al. Is an important thing. I mean, there are many people missing. And so it comes up in a broad spectrum of natural phenomena. I mean, one can just say it comes up everywhere, but if we don't say that, these are a few places where it comes up. And again, this dot is very important because there are many things that are left out. These examples that I told you were sort of more non-strange examples. But it is known that they also come up from the very beginnings of quantum mechanics in quite a few phenomena which can be called strange. It's of course a vague term, but yes. So I will try to give one example of it. And so this is the example. It's the so-called Einstein, Podolsky, Rosen, Bell. These are the names of 4 people. So these 3 people in 1935 wrote a paper, and then there was another paper by John Bell. There are a few papers around 1960s, and we roughly call it like this. It's called used to be called a paradox. I mean, now inside quantum mechanics and quantum information, we understand it sort of. Maybe there is still something more to understand. So it should really be called Einstein, Podolsky, Rosen, Bell effect, and not a paradox. So but I'll still use it like this within inverted commas. Yeah. So I will not go through the mathematical derivation of it. I'll try to give you the assumptions and the result. So in this so-called paradox, we will make 2 assumptions. And this is the first assumption. This is that measured results. So measured results exist before measurement. And some people, including Einstein, enunciated it like this, that the moon's there, whether or not you are looking at it. So this is the first assumption. Silly looking assumption, but this is it. And the second assumption is this, that what you do here doesn't affect the results there. Yeah, I mean, but this, when you say here and there, these should be like really far apart. In the physicists' language, they should be so-called space-like separated, but you can think of like really far apart. So again, to go into this cartoon type sentence, I do this. If I cough here, it will not make a child in Rio ill. Yes? So these are the 2 assumptions that we make about arbitrary experiments that we want to do. And what these people strangely showed is that these 2 assumptions, the conjunction of these 2 assumptions is inconsistent with quantum mechanics. Yes? Of course, I mean, this is a cartoon. I mean, what I mean really is this. Just to make you smile, I write this. But even these 2 are really innocuous looking assumptions by themselves. And what these people show is that the conjunction of these 2 is inconsistent with quantum mechanics. And so there are names attached to these lines. So this first line is called reality, within the physics community, and the second line is called locality in the physics community. And so it's locality plus reality, that is the conjunction of this, that is inconsistent with quantum mechanics. And I mean, this the EPR Bell, these type of things are now really newspaper stuff. It comes up on and off in colloquial statements, and so there are often statements made like this, that quantum mechanics is non-local. What they really mean is that these two statements, and it had the meanings in the previous slide. What they really mean by that is that these two statements is inconsistent. The conjunction of them is inconsistent with quantum mechanics. Well, so this was sort of, may look like strange things that people have been doing, but not. But this has been checked experimentally in several physical substrates, and but these substrates are, as of now, small systems. They are not yet big systems like me and the child in Rio, but really 2 photons, 2 electrons, these type of things. But it has been tested in experiments, and these experiments are not really, there are still some troubles with them, believed to be technical troubles. And there are other strange effects that exist. I will not go into them, so-called Schrödinger cat. And many a times, there's something called entanglement that is at the heart of such strangeness in quantum mechanics. So this is really the reason that people would like to understand, study, know, prepare entanglement. So this is where we come. We try to understand what is entanglement. So consider, consider this expression is sort of an innocuous looking expression. These you think of them as, you can think of them as numbers. I will make them vectors later on. But currently you can think of them as numbers. So this is A into capital A plus A into capital B. It's good to think of them as complex numbers. You can think of them as real numbers, but inside quantum mechanics, where I will go later on, these become complex. And now you take this, and we learned in school that this can be, so-called, it can be factored, yes? I mean, and because this thing is really this. Yes, you can take A common and it becomes like this. Similarly, if you take a more complicated one, and this again we learned maybe after we on in our school, maybe in class 6 or something or 7, maybe we had this as the first sum, and then down at the end of the exercise there were expressions like this, and you can see that this can also be factored into. So, but remember, by factorizing, I am putting a constraint that the first factor must have only small letters, and the second factor must have only large letters, okay, capital letters. And so, both this one as well as this one can be factored into 2 factors. The first one has small letters and the second one is capital letters. Okay? Okay, fine. But you of course realize that there are guys or whatever, girls like this, expressions like this, which you will not be able to factor. You can prove this, that, and it's sort of easy to prove that this one you will not be able to factor. It is in the sense that it is non-factorizable into smalls and capitals. Expression of smalls multiplied by an expression of capitals is not possible. The point that I want to make is that this simple algebra, when applied to, if you don't think of them as complex numbers but vectors in a complex space, it becomes they become something that are called non-factorizable vectors. I will not define them. And so these vectors really live in something that is called a tensor product Hilbert space, is a mathematical structure. And quantum mechanics predicts that there exists a pair of physical systems, there can exist a pair of physical systems whose mathematical representation is a non-factorizable vector. A vector that looks something like this. These ones also exist in nature, but also these ones. Such a joint physical system is said to be in an entangled state. This, of course, I mean, for the people who already know the subject, I'm sure there are many of you who know the subject. So, for them, this is a very simplistic definition, but I wanted to address to a broad audience. So, how much time left? Okay. So, having defined entanglement, well, this was the definition. We know that this EPR-Bell paradox appears because there is entanglement. This we know, but we sort of not quite understand why it happens. We have some understanding of it, but not the full. So it is important to know what are the important characteristics, traits of entanglement, of entangled states. So I will, in the time left, I will try to tell you two of the important traits of entangled states. I will not go into what I am saying now. Is that what I will not say is that such entangled states, along with being useful in these strange phenomena or philosophical debates, it's also useful in many applications, in information transfer and so on. This I will not go into. So let me go into this. I will talk about these two important traits of entanglement. I will go them one by one, okay? So there's something called local versus global disorder. So there are many notions and quantifications of disorder in different fields of study, including in physics, that people try to understand what is disorder, and there is no one definition for it. There are different types of definitions, but we can agree on these two statements, that if there is no disorder, if there is no disorder, if full info about the system is available. Yeah, it's a trivial statement. If I have all the information, there is no disorder left. And there is full disorder if I have no information of the system left. Yes, so I'm just defining the 0 and the 1. I'm not defining the middle of the spectrum. How to go from the 0 to 1, there are many types of quantifications. I'm not going to that. And then there is no one definition. But with the 0 and the 1, we know that the minimum and the maximum. By the 0 and the 1, I'm calling no information and full information. And quantum mechanics predicts that there are quantum states of two system pairs for which one can have full information available about the system pair, but there is no information available about the individual ones. And I will not go into the mathematical details of how such a state can be prepared. I will only say that such a state is always an entangled state. And I will also try to tell you why it is so different from the classical world. I'll try to argue that such a thing cannot ever appear in the classical world. So, so classically this cannot happen because consider two flowers, one in the next room and another in the Yeshwantpur station. Yes? And we are told that one in the next room is either pink or blue. And now we assume that all the flowers in the world are either pink or blue. This is another assumption, okay? So, we have no information about the flower in the next room because all the flowers in the world are either pink or blue. And we are told that the flower in the next room is either pink or blue. That's no information. But now, once we know that, it cannot happen that we have full information about the color of both the flowers. I have no information about the flower of the next room. Now it cannot happen that I know the colors of both the flowers in the next room and in the Yeshwantpur station. Yes? So classically, these type of things doesn't happen. But in the quantum world, you can have entangled states for which this is exactly true. That you have no information about one system, but you have full information about the total system. And not only that, it's not really theory. You can actually prepare such states. I mean, this easy is within, I'm a theorist, okay? I cannot prepare this, but I'm told by experimentalists that they can regularly prepare it. I mean, this is rather easy to prepare, especially in photonic systems, it's very easy. Even in ions and all, they can prepare it. And they have done it in several physical substrates. Something. So in the last few minutes that I'm left with, I will go to the last topic. Is that, so I was talking about this one trait. I'll go to the next trait. Yeah, the first trait that I was talking about was that local systems can be disordered where the global one is not. In this second topic, I will talk about something called monogamy. So we'll talk about monogamy of entanglement. But what is monogamy? We all know this. Yes, this is something like monogamy. I mean, these two people are interested with each other and completely oblivious of this guy. This is something like a monogamy. But what is the monogamy of entanglement? By monogamy of entanglement, we mean that if there are two people, we call them Alice and Bob. So these are our Alice and Bob. And if Alice and Bob share maximal entanglement, the maximal entanglement that is possible, I have defined what is entanglement, but I have not defined how to quantify entanglement. Yes, I mean, but that can be done. Once you do that, you can see someone has less entanglement, someone has more entanglement, and you go to the maximal possible. And now you assume that these two people are in a state that shares maximal entanglement. And now monogamy of entanglement says that if once that is true, then they can't share any entanglement with this person. None of them. Neither this nor this. And this is what is monogamy of entanglement. This is a qualitative statement that I have made. You can quantify it, and so you can. It's not only about maximal entanglement. People have derived several inequalities that connects the entanglements, all the two-party entanglements between these three people. So I will not go into the derivation of those inequalities. I will, on the other hand, try to argue that such a thing is not there in the classical world. In the classical correlations are not monogamous. And it's easy to see actually. And we go to our flowers, but this time there are 3 flowers. Yeah, whenever you have monogamy, we know from Hindi films that monogamy you have to have at least 3 people. So, we have 3 flowers, and we are told again the same condition that they're either all 3 pink or all 3 are blue. Yes, so it's like all 3 are looking downwards, all 3 are looking upwards, something like this. But in that state, we lose 1 flower. Yes, so we had 3 flowers, all 3 were looking up or down, and in that situation, we lose 1 of them. Now, the remaining 2 flowers that are left, so all 3 were looking up or down, so is all pink or all blue, and now you lose 1 flower. When you lose that flower, the remaining 2 flowers are either looking upwards both, or both are looking downwards. Yes, either both are blue or both are pink. So this means that these 2 flowers have the maximal amount of classical correlation that is there, that one can have in this situation, in this system. And this is true irrespective of which flower you lose. If you lose this flower, then these 2 are both pink or both blue. But if you lose this flower, these 2 are also both pink or both blue. So here you are violating monogamy to the maximum possible. All 3 of them are maximally correlated. All 3 options, these two, and these 2, all of them are maximally correlated. So monogamy is not there in for classical correlations. But what I said before, that for quantum states, there are quantum correlated states, and again those can be easily prepared, easily meaning that experimentalists can prepare them rather easily in several substrates. So I sort of come to the end, and entangled states can lead to demonstration of the EPR-Bell paradox. That is, entangled states can lead to inconsistency with the conjunction of the 2 assumptions. These 2, if I take these 2 assumptions together, then quantum mechanics is inconsistent with that, and to demonstrate that, one has to use entangled states. And this is all I wish to say. So so quantum theory predicts pairs of systems in entangled situations called states, and many have already been prepared in laboratories. And they are interesting. They're different from states of pairs of classical systems. So they can show monogamy, for example, which classical correlations do not show. And they can lead to the demonstration of EPR-Bell-like paradox. And what I did not speak about was that it's not only these so-called strange type phenomena, but there are things that these entangled states can do that classical states cannot do, and these can be put into use to do computation that is better than any classical computer can do, to send information in ways that a classical channel is not able to send, but this I have not presented to you. So, thank you. This is the group of people that we work with, and some of them are here in the Harishchandra Research Institute in Allahabad.
Thank you, Professor Ujjwal Sen. I invite you to please occupy your seat. First of all, sir, you have a very incredible way with words, actually. You can describe things, very complicated things, in a very simple, lucid way. So it was very difficult for me to make a summary, but I have to say this is the first time that I am looking at entanglement from so many different perspectives: locality versus reality, definition, local versus global disorder, monogamous entanglement, and how they can be very different from the classical states that we see. So, with this, I open the house for discussion. I've been told that we don't have much time. I want the questions to be very specific, and please also mention to whom the question is directed, and we'll try to make it very specific and concise. Yeah, please.
Thank you so much for your talks. This question is for Professor Ujjwal Sen. So I'm wondering if you would be able to, since the explanation or the definition was just with mathematical variables, so I don't really have any picture of the actual phenomena that you're referring to. So in terms of actual subatomic phenomena, could you, take those variables, the small a, the big A, small b, big B, and what do they actually represent in terms of actual phenomena?
Mm-hmm.
And then related to that, when you talked about knowing in the next room that there are two flowers which are either pink or blue, why is that not knowing information about the system? Because it seems like, that eliminates knowing that, you have the information, they're not black, they're not white, they're not green. So how is that not information?
So thank you for the question. The first question is that how to realize such a physical system. So if you remember, there was this A's and B's, small letters and big letters. So the small letters would represent one physical system, and the large letters would represent another physical system. And when I write a small a and a small b, they really mean two dimensions, 2 degrees of freedom, two directions in space, in the spin space, let's say. So if it can be many different things. So if it is a polarization of a photon, it can be the photon that is polarized like this or polarized like this. It's anti-clockwise or clockwise. Or it can be, if it is spin, then it can be spin up in the z direction and spin down in the z direction. And similarly the other one. Or it can be one photon and one spin. And these have actually been experimentally prepared in the lab, in many labs around the world. About the other question about the flowers, yes, but there was the assumption that for the explanation that all the flowers in the world are either pink or blue. So there are no black flowers. Otherwise, of course, you can make the argument when you have black, white, purple, other flowers as well, but it makes the argument more complicated. So to make the argument simple, I defined a world where there are only 2 types of flowers, black, blue and pink.
One thing is that you can't distinguish them from any other system of the environment.
No, there's no environment. My universe contains only flowers and 2 types of flowers. This is how I am argumenting here. This is my very simple universe where I am trying to argue the point.
Thank you, Dr. Professor Ujjwal. Yeah.
Yeah, this question is to the Venerable. Venerable, you said about the micro-reality having cause and effect, the macro. Since now you saw so many cause and effects here, which Pramana Grantha would you employ to explain this cause and effect? Which Pramana Grantha would you employ to explain these cause and effects which you saw in the lecture given by the professor?
Pramana Grantha.
Pramana Grantha.
Okay. Which text?
Yeah. Which Pramana Grantha would you employ to explain this phenomena?
Which phenomena?
The entanglement phenomena.
Okay. So basically, we see that this interesting, very serious point. In fact, we talked about the 2 truths. So that is very clearly indicated in Heart Sutra. And there are many sutras, such sutras. These are the texts on which that has been explained. And then on top of that, not only that, these sutras, the direct words of the Buddha, you find these sutras talking about the cause-effect relationship and the beyond what the cause-effect relationship, the ultimate reality, objectivity is not there. All these things are so well said there. For example, Heart Sutra is one thing. Another one is the Vajrachetika Sutra. Is again, there are many such sutras there. And then these sutras, they are further being explained on the basis of the different philosophical schools. And most interestingly, there are two. One which talks about the subjectivity in the form this morning. One later talked about the idealistic view, which is more what we would call as the Chetamantra philosophy. And then the other one also talks about the subjectivity, that nothing exists objectively subjective, and that is what is technically known as the Madhyamika school. So the same text being interpreted by various philosophical schools, and amongst these are two which are the most prominent: Chetamantra school and the Madhyamika school.
Thank you, sir. Just two more we can take, maybe. So next we will take from sir here. Okay.
Good afternoon. My question is for Venerable. Venerable, basically free will is a precursor to karma, right? So how do I actually go about free will? Actually, whatever imperial experience we are experiencing is a part of karma that has been performed in the past or whatever. But at given this point of time, we have a free will, right? So how actually you correlate this, and some kind of confusion is there? Can you just clarify that?
That's true, because there's confusion. There's lots of debates happening. There's a confusion there. That's true. And so for that, first we have to have a very clear understanding of the two truths. This is what we have to study. So therefore we have Chobar Sumling Buddhist Center there. So people have to go there, study there. And the one purpose of this is that people crave for knowledge. People crave for knowledge. Even the brilliant neuroscientists, very senior neuroscientists, physicists in Israel, I meet many of them. And then the extremely renowned neuroscientist, I would just brush through all, I just went through so very briefly. There's one thing: what is the ontological reality out there? That the absence of the ontological reality is the ontological reality. So this, we put it as emptiness of objectivity is the objectivity of the object. I said it, and this neuroscientist, very senior, highly respected, he was like a small child memorizing it. He was so fascinated by this. So this is what you will not find anywhere in Bengaluru, only in Chobar Sumling Center. Thank you.
Thank you, Venerable. Yeah.
It's for Gashe Dorji. About the free will, so at the micro level, it's a free will. At the macro, it becomes a cause and effect, if I got it right.
Okay, so on the macro is the free will, micro is the cause and effect.
Okay, I mean, from my perspective, how I look at when we are in a deep states of meditation, right? So whatever we think, we can do it properly. But if we are disturbed, so our free will is not free will. It depends upon other cause and effects.
That's true.
If you see from
the
that...
fabric of the free will is cause and effect.
Yeah.
So therefore, the three levels of dependent origination.
Right.
The first one is the cause effect. Third one is the mental imputation.
Okay.
Mental imputation. So there's overlap of the first and third. And in fact, the free will that we're talking about, it is also a mental state. And all mental activities should necessarily fall under the category of the cause and effect. And yet, within that, there's a free will. So in a way, if it confuses you, which means that you understand something. You're getting it? Yeah. So free will is there. So the way what you're doing is that don't be philosophical. when I say don't be philosophical, oh, what is not philosophical? You are philosophers. Now you're going to philosophy.
Okay.
You're getting it? So there I said that when you go on that one level, subjectivity, say when you see this water, if you want to enjoy this water, don't go into the electrons, protons. You will not enjoy water. So just stay there on that level. Then the water makes water makes sense on that level. You go a little deeper. What is this water made of? You go to the chemist, they will say it's H2O. Go to physics, it will become worse. Electrons, protons, neutrons. You're getting it? Then you will not enjoy water. So therefore, water functions on one perspective. Beyond that, it operates as 2 hydrogen and 1 oxygen. Beyond that, it operates as electrons, protons, neutrons. So therefore, the free will operates on one level, and then you analyze a little bit deeper, you go into the cause effect. Even the free will, it operates on the basis of the cause and effect. But the free will is what we see on one level, and then you go a little deeper, you see the final cause, minute cause effect operation. I give an example.
So, can we say like this, just to simplify, to get something? So, when we are in the subtle states of mind, that means in a meditative states, okay? So, at that time, there's less chance of getting caught up in the web of karma. And when you are in a grosser states of mind, probably you're disturbed. At that time, you can get entangled into the more like a karmic mesh. So, our choice lies to be centered. And there is the free will exists. I've been thinking about this for 10 years.
Okay,
So
in fact, I really
how I feel about
appreciate your question about how to discuss this in the context of the karma. When you are into a very refined meditation, then you have a more free will to stay away from karmic effect. When you're mentally disturbed, when the meditation is not good, disturbed, then you are more into the sway of the karma. Is your question. So basically, it is not like that. Say, when you're in a very refined meditation, you're going to the effect of a very smooth karmic operation. When you're into a very disturbed meditation, disturbed mind, when you go into a very rough karmic operation, both are karmic operation. You're getting it? So therefore, I did not really get time. Otherwise, I really need to explain what is karma. Karma is nothing really somewhere outside there. It is your own mental thinking, the intention within you. Intention to operate. Karma means action. Action must happen. For example, I say this mic. This mic, it will not operate on its own. Whereas my hand operates on its own. I want to move it like this, it's my will. I don't want to move it like it's my will. So that this karma is the action, bodily action, verbal action, mental action. And these actions operate on the basis of my intention. That intention is the karma, and that intention is the free will. So there's no contradiction. Instead, there is the compatibility there. There is the superimposition happening there. Free will, the intention, this is the free will. Intention, this is the karma. So karma and the free will, there's no contradiction. This is how these two work compatibly.
Thank you. Thank you, sir. Just one question we can take.
So, you just said about free will, right? So, you said that in the microscopic level, there is the cause-effect thing, and the macro level, that's the free will. So, the scale, like you were saying, small or big, that depends on our perspective, right? So, how does it mean when you say big and small, like micro and macro? So, I can say your micro, my macro, right?
Okay, so this is, I hope you all followed the question. So when I speak about the micro and the macro, I do not say microscopic. I say micro. You're getting it? Microscopic is very different. Micro and macro, how do you define what is micro, what is macro? Right? There's no objectively existing micro and macro. It's all relative. Like where the relativity operates. Theory of relativity, things make sense only in relative to a frame of reference. Only with the frame of reference, then things will make sense as high speed, low speed, big, small, good, bad, all these things. There's nothing there objectively there. So therefore, since there's nothing really objectively there, everything exists in relative terms. Everything exists by dependence on the frame of reference. But depends on frame of reference. So therefore, with that respect, you have to say, with respect to the earth, this hall is small. With respect to my room, this hall is huge. It's a relativity. So with this, so as compared to the free will that we are talking about, let's for example say I'm speaking. I use my free will to speak. So that is the macro with respect to the finer causal factors which made me to speak. I like to speak. I have the energy to speak. If I don't have the energy, even if I like to speak, I cannot speak. So I have the energy. And number two, you asked me the question. All these factors combined together made me to feel like talking. So the overall, the bigger picture is the free will, and the minute picture is the causes responsible for making me to use my free will. Thank you.
Thank you, sir. Yeah. So I end the session. In the end, I would like to thank both the speakers. Amazing presentation. It was very enlightening for me actually, and I hope it was the same for everyone. We are going to end this session, and yeah.
Thank you to all the panelists for a wonderful session. Now may I request our chair, Dr. Ravi Prakash Ji, to honor the speakers with a khata and a souvenir. Venerable Geshe Dorji Damdila. And Professor Ujjwal Sen. Thank you. We will now break for tea. The coming up session is on non-locality and individuation in quantum physics, Buddhist philosophy and neuroscience. We will resume the session. We will start the session at 3:20. Thank you.